The first problem we're going to look at is called an update anomaly, and we're going to look at it in the context of the functional dependency R determines W. So suppose we want to give Achu a raise, all right, want to raise his wage from 10 to 12. Can we modify the wage of just Achu? And the answer is no, because that tuple then would be inconsistent with Smiley and Marian, both of whom are also rating 8. So we're stuck here. We can't give Achu a raise, at least not without making sure that we also give everyone else with rating 8 a raise. So that's difficult, right? Now we're going to have to make sure that all our updates turn into multiple updates, and we could easily end up with an inconsistent table. So that's called an update anomaly. The second problem we're going to look at is called an insertion anomaly. What if we want to insert an employee, but we don't know the hourly wage for his or her rating? Okay, so we want to insert a brand new employee with a rating like 6, for example. What should we put for the wage? And the answer is we don't know. In fact, there may be a proper wage for rating 6, but we don't know what it is. And so then we either have to invent a value, or we have to leave the value blank. We're stuck not actually giving this person a wage. So we have no reference here to any established truth for this value 6. So that's called an insertion anomaly. And then finally, and this may be the most insidious of the anomalies, is what's called a deletion anomaly. If we delete both Smethurst and Guldu, all employees with rating 5, then we lose the information that rating 5 people should have wage 7. So in that case, we actually forget the established truth simply by removing examples of that established truth from the database. Okay, that's called a deletion anomaly. So all of these anomalies are evil. And so how are we going to detect the redundancy that causes these anomalies? Well, let's think about this. Why is R determines W a problem, but S determines W not a problem? Because after all, S determines snillerwe, which also includes W, right? S determines everything. Well, in this hourly emps table, note that R is not a key. So any pair, say 8, 10, for example, could appear multiple times. Any RW pair can appear multiple times. By contrast, S is a candidate key. In fact, it's primary key. So each pair of S, W, like the first row, Adishu's social security number and his wage, that's stored exactly once. There is no redundancy because S, which is on the left-hand side of the functional dependency, is unique. It's a candidate key. So it seems like there's something about the left-hand side of a functional dependency being a candidate key that doesn't cause redundancy. But if the left-hand side isn't a candidate key, we've got problems. So what we do here is we decompose the relation into two parts. We sort of chop the relation into two. But in fact, it's not strictly chopping. We're keeping some overlapping columns between the two sides. We've decomposed hourly emps into hourly emps 2, which no longer has W, and wages, which has R and W. And the functional dependencies are used to drive the decision about how to decompose the relation. R determines W was the FD that was causing the problem. So we decomposed snillerwe into a relation hourly emps 2 that doesn't have the right side of the functional dependency. It has no W, but it does have the left side, R. And then we create a separate lookup table, which has the pair R and W. Now notice what's interesting about wages. We know that R determines W, that was given. We also know that R determines R, which is a trivial dependency, which means that R determines the entire wages table. It determines the columns R and W. Okay? So the functional dependency R determines W has a candidate key on the left-hand side, R, in the wages table. So it's not causing us any trouble over there. And on the left-hand side, W doesn't exist anymore, so R determines W isn't causing us any trouble on the left-hand side. And basically now we're in good shape. That R determines W functional dependency is now only in a table where R, the left-hand side, is a candidate key. And this has caused the redundancy to go away.